T-minus 3, 2, 1.
Atlas engine ignition.
Liftoff of the United Launch Alliance Delta IV Heavy rocket.
At Space Launch Complex 41, an Atlas V rocket is fueled and ready to launch the NROL-52 mission for the National Reconnaissance Office. Good morning and welcome to Cape Canaveral Air Force Station. I'm Anton Kolomitz. I'm a mechanical engineer for ULA's Human and Commercial Systems Group, and I'm joining you today for mission control inside the Atlas Spaceflight Operations Center. The launch team is not currently working any issues, and we're proceeding towards liftoff at 4:03 a.m. Eastern Time. A few seconds from now, the count will enter a planned 15-minute hold. There are 2 planned holds in our nearly 7-hour launch count. The planned holds give our team additional time to resolve any issues prior to entering the terminal count at T-minus 4 minutes. At the request of our customer, today's live coverage will conclude following payload fairing jettison, which is scheduled to take place about 4.5 minutes after liftoff. Clay Flynn, the 45th Space Wing's weather officer, recently provided the final forecast, and the weather is not currently within today's launch commit criteria. However, we are still proceeding to a T0 of 4:03 a.m. The probability of violating launch constraints is 60%. Ground winds are 18 knots out of the east, and the temperature is 80 degrees Fahrenheit. After liftoff, the Atlas V rocket will fly in a southeasterly heading away from our launch pads at Cape Canaveral. Let's take a look at what else we can expect to see this morning.
The following profile details the important events of this mission using approximate times.
5, 4, 3, 2. We have RD-180 ignition, and we have liftoff of the United Launch Alliance Atlas V rocket.
The Atlas RD-180 main engine and 2 solid rocket boosters ignite to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 47 seconds. At 52 seconds, the vehicle experiences maximum dynamic pressure. At 1 minute 31 seconds, the 2 SRBs burn out, followed by jettison 38 seconds later. Approaching booster engine cutoff, the Atlas V is burning propellant at a rate of 2,028 pounds per second, traveling at approximately 11,588 miles per hour and located 67 miles in altitude and 209 miles downrange. Booster engine cutoff occurs 4 minutes, 10 seconds after liftoff. 6 seconds later, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. At 4 minutes 34 seconds, the payload fairing is jettisoned.
NROL-52 is the 74th Atlas V mission and the 122nd ULA flight. This mission uses the Atlas V 421 configuration. Produced in Decatur, Alabama and Harlingen, Texas, the Atlas V 421 includes a common core booster powered by an RD-180 engine, 2 Aerojet Rocketdyne solid rocket boosters, and a Centaur second stage powered by an Aerojet Rocketdyne RL-10C1 engine. The satellite is protected during ascent by a 4-meter diameter payload fairing. On September 26th, the NROL-52 payload encapsulated inside the fairing was transported to the VIF and mated to the Centaur. The launch countdown begins with moving the rocket from the VIF to the pad. On Tuesday, the quarter-mile trip began using 6 components to complete the 20-minute trip. Weighing in at about 2 million pounds, the Mobile Launch Platforms, or MLP, supports the rocket and contains air conditioning, electrical, and commodities, while the undercarriages bear the weight of the MLP and the rocket. 2 rail cars lead the move, with the payload van providing communication to the payload, while the ground van houses the ground support for the rocket. At the rear of the convoy, the portable environmental control system provides air conditioning to the payload and rocket. Finally, track mobiles provide the power to move the 3.5 million pound convoy. The Atlas V rocket stands 195 feet tall, or about 20 stories, and weighs about 1 million pounds fully fueled. The RD-180 main engines and 2 solid rocket boosters produce approximately 1.5 million pounds of thrust to lift the rocket off the pad and begin its trip to orbit. Today's launch is for the National Reconnaissance Office, or NRO. The NRO is a joint organization engaged in research and development, acquisition, launch, and operation of innovative overhead reconnaissance systems necessary to meet the needs of the intelligence community and the Department of Defense. The NRO is recognized for its transformational intelligence collection systems that are used to develop highly accurate military targeting data, support international peacekeeping and humanitarian relief operations, and to assess the impact of natural disasters. The NRO provided artwork for today's mission, which is visible on the payload fairing. The mission patch features an eagle, which represents the NRO's power and strength, as well as the L-52 payload joining the existing constellation of NRO capabilities. Defensor Libertatis, which translates to Defender of Freedom, symbolizes the NRO's commitment to providing critical capabilities and their commitment to the greater mission.
L minus 12 minutes.
Earlier this week, I met with ULA Sarah Miller to discuss her role and how she prepares for launch. Let's take a look at our conversation at Space Launch Complex 41.
So Sarah, give us an idea of what it is that you do here at ULA and how you got here.
I am an airborne electrical engineer for the Atlas program here at ULA. My time actually started as an intern in the summer of 2014. That internship then turned into a full-time job after I finished my degree. Now, as a full-time engineer here at ULA, I'm responsible for everything electrical that's on the rocket itself. This includes the electrical connections between the stages, the batteries, the flight computer, as well as the ordnance and instrumentation.
So you will actually be on console for this launch in the mission control area for Atlas.
That is correct. I will be monitoring all of my systems data, which includes all of the avionics box temperatures, currents, voltages, making sure that each of the boxes responds appropriately to the tests that we complete on launch day to verify that the system is ready for launch.
So your job sounds really cool, and to actually be there in mission control and see these rockets launch is just amazing. What would you say is your most favorite part of your job?
I have two favorite parts of my job. The first is, of course, launch day. In that T-minus 4 minutes and counting scenario when the anticipation is building in the Launch Control Center, it's a feeling that you can't describe. You culminate all of this hard work that the entire team across the country has done into this magnificent site. The second is that when we are processing in the VIF, which is our vertical integration facility, I have opportunities to go inside the rocket to do some of the testing. Working with my team inside the rocket is something that people don't really realize that you have to do. They think that things are always on the outside, but on the inside we have different components that have to be checked out, and as part of that I get to be in there.
So, well, it sounds like you've had a lot of good experiences out here at Cape Canaveral and been a part of a lot of different missions. What would you say is the most memorable or most exciting mission that you had?
My most memorable would be my internship launch. That was the first launch that I got to experience. It was a GPS 2F7 launch back in the summer of 2014. And during that time, I got to experience and get hooked on this amazing industry.
Well, Sarah, you're playing a key part getting us into space with ULA's rockets. Thank you for everything that you do. We definitely couldn't have done it without you and the hundreds of people all around the country that help get these missions from concept to reality and launch to space.
It's definitely a team effort. Thank you for having me.
Thank you.
OSM, LC. OSM. At step 890, place SRB ignition SNA switch in the enabled position. SRB ignition enabled. Verify the FCO, RCO, and OSM hold fire switches are in the proceed position. Ready to proceed. Verify redline monitor and event table are in the correct configuration for terminal count. Verified. RC, verify solar radiation acceptable for launch. Verified. Launch on time, verified. Roger.
We remain in the planned 15-minute built-in hold as preparations for launch continue. In a few moments, launch conductor Dylan Rice will poll the launch team for the final go to pick up the countdown. 29 engineers and managers are polled for system status and readiness to proceed with the launch. This is the final status check for all Atlas vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The readiness poll includes hydraulics, pad water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as launch conductor Dylan Rice performs the final polling of the team. The launch team has adjusted the official launch time to 4:08 a.m., so polling will start in about 3 minutes. Looks like we have a new T0 of 4:13 a.m. Eastern Time. We're keeping an eye on the weather. Right now we are currently in violation of 2 weather constraints. This is a mission control. We've got a new launch time of 4:18. Again, we're still violating weather constraints, keeping an eye on it, taking advantage of any opportunity. This is Mission Control. We have a new launch time of 4:23 Eastern Time. Again, we're still in violation of our 2 weather constraints.
LC, this is LC in Channel 1.
LC.
Yes, sir. Please coordinate.
This is Mission Control. We've got a new launch time of 4:28 a.m. Eastern Time. We did manage to clear one of our launch constraints, still waiting on a few more minutes to clear the other.
Reporting a new T0 of the range of 0828 Zulu with a countdown resumption time of 0824 Zulu.
Roger, copy, and work.
Timer, LC.
Timer on 1.
Please set the clock for a new T0 of 0828 Zulu.
Roger, set for 0828 Zulu.
Roger.
This is Mission Control. We've established a new T0 time of 4:28 a.m. Eastern Time, so polling will take place in about 2 minutes.
Picking up at step 970, LC switch to ready position. All steps complete prior to the status check.
In a few moments, Launch Conductor Dylan Rice will poll the launch team for the final go to pick up the countdown. Let's listen in as he performs the final polling of the team.
Minus 7 minutes.
Status check to proceed with terminal count, Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2. Go. LH2.
Go.
HASGAS. Go. Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFSDS.
Go.
Flight control.
Go.
GCQ.
Go.
COM. Go. Timer.
Go.
Umbilical.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
AC is go.
Range coordinator.
Not ready.
Roger. Launch director.
LC, we have a new T0 from the MD. Please put into place 0831 Zulu.
Range coordinator LC.
RC and 1.
Please coordinate a new T0 of the range with 0831 Zulu.
Roger, copy.
And for the team on that one, we're going to stand by here. We're going to pick up the status check with the range coordinator. Please maintain your systems at a state of readiness.
This is Mission Control. We have a new T0 time of 4:31 a.m. Eastern Time.
Roger. Set for 0831 Zulu.
Roger.
Minus 8 minutes.
LCRC Net 1.
Go.
Unit 20 of 0831 Zulu has been coordinated through by the range.
Roger. And RC, with that, your status check receiver terminal count.
Ready.
Roger. Launch
Clear to
director.
proceed.
Launch director.
The launch vehicle is ready.
Roger. Mission director.
You have permission to launch.
Proceeding with the count. Timer set count to start at 0827 Zulu for a plan T0 of 0831 Zulu.
Roger, the count will start at 0827 Zulu for a plan T0 of 0831 Zulu.
Roger.
Polling is complete and the launch team has given the go for launch. From T-minus 4 minutes until launch, you will be listening to Dylan Rice and his team performing the final steps in the countdown procedure. You'll hear the team confirm securing of Atlas liquid oxygen topping, followed by the call to transfer the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute and 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur liquid hydrogen and liquid oxygen topping activity. At T-minus 1 minute and 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, the Atlas tanks will be verified at flight pressures, followed with verification of the Centaur tank pressures. A final status check of Atlas, Centaur, and NROL-52 readiness is conducted at T-minus 25 seconds. Seconds before liftoff, the RD-180 engine ignites and performs a health check, followed by ignition of the 2 solid rocket boosters to lift the vehicle off the pad. After liftoff, you'll hear the voice of Marty Melanowski providing flight commentary.
Is configured for launch.
Start list data capture.
Roger.
All steps complete prior to terminal count.
On my mark, the time will be T-minus 4 minutes and counting. 3, 2, 1, mark.
359. 355.
Ground pyros enabled.
The countdown clock has resumed and we are go for launch at 4:13 a.m. Eastern. Corrected, 4:31 a.m. Eastern.
340. 330. 315. 3 minutes.
Securing LOP topping. Atlas tanks to flight pressure.
250.
FTS internal.
2 minutes. 159, 158, 157,
Vehicle internal.
155,
Launch sequence start.
150,
Securing Centaur LH2. Securing Centaur LO2.
Hold. This is weather. Weather's no go. LC switch not ready. Clock is stopped at T-minus 1 minute, 37 seconds. All personnel. Turn to Operation 80. Page 141.
Centaur tank pressures are stable.
Roger.
Atlas tank pressures are stable.
Roger. Flight control LC.
Go ahead.
Okay, looking for your status at Operation 80, Step 10.
Yeah, we hold at approximately T-minus 97 seconds. Elevator.
Roger, and are you ready to reset the clock to T-minus 4 and holding?
Roger.
Timer, reset the countdown clock to T-minus 4 minutes and holding.
Roger. LC, this flight control.
Go, flight control.
Yes, step 30, SFAP's inactive and FCS is pre-flight mode.
Roger. OSM, place SRB ignition SNA switch to disabled position.
SRB ignition disabled.
All stations recycle systems back to T-minus 4 minutes and holding configuration. Hold occurred at T-minus 1 minute, 37 seconds. Report status at completion.
LB, this is the MD on channel 1. LB, we are scrubbing the launch attempt for today. Proceed with preparations for an attempt in 24 hours.
Welcome. LC, this is the LD on channel 1. Please set up for a 24-hour recycle.
LC copied.
This is Atlas Mission Control. It has been confirmed that we will not continue with Atlas 5 NROL-52 launch activities this morning. We have a 24-hour recycle, so our next launch attempt will be tomorrow at 3:59 a.m. Eastern. For the most up-to-date information, please visit ulalaunch.com, follow us at ULA Launch, or call 1-877-ULA-4321. This concludes today's broadcast. I'm Anton Kolomietz. Thank you for joining us.